Hey everybody, it's Sonic here, and I'm going to give you your first true Sonic screencast of the year, and this one is all about solids, liquids, and gases. This particular screencast is screencast number 1. You are expected to take notes on this. It won't be long. These notes can be used on the homework quiz for this week. Honors, you will be doing Sonic Screencast 1 and Sonic Screencast 2. This particular screencast, again, is about solids, liquids, and gases. If we go over here to a simple diagram, we've seen a few of these before. Think of water as your choice of matter. It's a compound, as we've talked about before. It is a pure substance, which means that it can't be broken apart easily. It's got chemical bonds that hold hydrogen atoms to oxygen atoms. But you can freeze it to a solid. You can add heat energy to it. So one of the things that's important here, and we've reflected on this in your foldable, is that as you add heat energy to a substance, you slowly begin, depending on the substance, to change its state. So a solid, which has particles in a very fixed pattern, will vibrate. They still move, but as energy is added to them, they slowly break apart. They break their bonds and slide over one another, and this is where we get the state of matter we call a liquid. By definition, a liquid has no shape. It takes the shape of its container, and it has particles that are close together but slide over one another. It has a fixed volume. Back to a solid keeps its shape. It will not take the shape of its container, and its particles, while close together, are in fixed patterns, okay? So that's sort of the comparison between a solid into a liquid. If you add enough heat to that liquid, it will turn then into a gas. And the particles in a gas fly all over the place. Gas particles, or gas in particular, does not have a fixed volume. It does not have a fixed shape, and it spreads out to fill the container that it is in. Here's another diagram to kind of illustrate the same thing. You've got that temperature line across the bottom, and actually that temperature line looks like it is in reverse, isn't it? You would want to add the heat to go this way. So I'm actually a big fan of this diagram right here. This one is a little bit better. We add the heat going up. This way the heat should be going to the left. But again, you have a solid, liquid, and a gas. Now here's a quick diagram to illustrate everything that I just stated. In your foldable, you definitely want those 3 separate diagrams. Particle arrangement of a solid, particle arrangement of a liquid, particle arrangement of a gas. Notice you have regular arrangement, randomly arranged for a gas. The movement, they vibrate but in a fixed position when it comes to a solid. In a liquid, they move around each other. And in a gas, they bounce around completely in all directions. The closeness of the particles we've talked about, very close, and then completely far apart. The one thing that's not listed here is the concept of volume. In a solid, we have a fixed volume. In a liquid, we have a fixed volume, and in a gas, we do not have a fixed volume. One of the other things that I'm going to show you is something that we talked about in class. You guys remember our slime. Now, our slime was placed on top of this Clorox container. Somebody, I think in my 3rd hour, did this, and I've been replicating the experience since because it illustrates something very specific. Our slime, we've decided, appears to have sort of the qualities of a solid and the qualities of a liquid all at the same time. See, on one hand, it has a fixed volume. It doesn't matter what shape I put this slime into, it has a fixed volume. I can put it in a container. It'll take the shape of the container it's in. The particles appear to flow over one another. But one thing that it does differently than a liquid is it sort of shears apart like that. It breaks completely apart. And that does not hold true for a typical liquid. So that gives you kind of a different impression on what this could be. We talked a little bit about oobleck and how cornstarch and water appears to act somewhat like a liquid, also appears to act like a solid. We talked about shaving cream, Jell-O. These are all substances that are tricky, and we illustrate those simply to express to you that when we look at the different characteristics, fixed volume, fixed shape, particle arrangement, how the particles move, sometimes we have these weird exceptions. Because if you start looking at the exceptions, you can get a handle on what traditional solids and liquids and gases look like or behave like. So, in any event, by the way, if you want to make this, tell your mom and dad that it's easy to make and it's completely safe. You just need the borax, okay? B-O-R-A-X. There's not a ton else that I need you to know about this. A lot of this is repeat. Feel free to rewind, pause, watch it again. But the information that I talked about in this video, specific points that I made, will show up on the quiz on Friday. All right? So I'm going to